right? So in the last videos, sir, let me revise for a few minutes whatever we discussed from day one. Sir, we have given introduction to, okay, introduction to algorithms, and even we discussed about introduction to data structures. Okay, next and after that we have seen what are the applications of data structures where we can use in real time. Okay, next and after that we have seen, sir, steps to prepare. Okay, steps to prepare algorithms. If I want to prepare any algorithm, what steps we have to use, and the steps to prepare, okay, steps to prepare flow chart. Of course we have not discussed in detail about this, but just we have taken one small program and we have analyzed that. And even, sir, we have seen steps to implement. Okay, steps to implement a program in Java. Suppose if I have an algorithm, how you can able to implement that algorithm into Java programming. Almost we have seen some sample programs also. So with various cases like different logics. Sir, how many programs we covered? Almost 10 programs we covered. Then we have seen, okay, analysis of algorithms. So what kind of analysis is there? Sir, first we have seen calculation of space complexity. Okay, space complexity calculation. Okay, next and after that, so time complexity calculation also we have seen. So these are the things which we discussed in the last videos very clearly. Now, today I'm going for, sir, measuring the algorithm statistics. Sir, if I want to measure the algorithms, so we have to go for some best case, average case, worst case analysis are there. Okay, so for any algorithm, we have to consider these cases. Sir, here, how you can able to analyze these? Today I will take one small program and I will explain how you can able to analyze the algorithms, and a small concept only today. Tomorrow we are going to talk about these asymptotic notations with various example. With that, time complexity and space complexity theoretical part will be over. Then in the next week I am going to start recursion. Maybe 1.5 week we are going to explore this recursion, like we have various algorithms are there, how you can able to solve all those things in detail we will discuss. Sir, now, sir, best case. Okay, best case. Then I can say worst case, and average case analysis. Sir, if you take any algorithm, okay, if you take any algorithm, these are the, sir, three cases that we have to measure. Okay, for any algorithm, these are the three cases that we have to measure. Sir, best case means what? Best case means what? Very simple, sir. If we are, okay, if we are looking for a solution, okay, if we are looking for a solution, okay, sir, which is available, which is available at very first case, which is available at very first location. Okay, sir, then, so such type of, okay, such type of a case is called as best case, sir, is called as best case. I will take one example. For example, consider I have some elements are there like 11, 12, 13, 14, 15, 16. Now in these I want to search for an element called 11. Sir, how many comparisons is required? Only at very first comparison, itself we got the result. So hence we can say this particular search is nothing but best case. Okay, this particular case is nothing but best case. This is nothing but, sir, what is mean by best case? Second one, what is the second one? Sir, we have worst case analysis is also there. Sir, what is mean by worst case analysis? So if we are searching, or if we are looking for a data, Okay, so available which is available at the last position, at the last position, or may not be available. Okay, may not be available. So then, so such a type of cases are called as, sir, worst case. Such a type of cases are called as worst case. Best example, if you take this example alone, so there are two possibilities I can able to explain. For example, if I am searching for an element called 16, sir, how many comparisons here is required? Sir, 1, 2, 3, 4, 5, 6 comparisons is required. Okay, at last comparison we got the result. For example, assume I want to search for the key called 17. So how many comparisons is required? So here we have to do 6 comparison, but here after comparison, the result is nothing but a success. Here the result is nothing but a failure, because the data which you are looking is not available. Even though after comparing 6 comparisons, the data is not available. But here, after comparing 6 locations, at the last location, the data is available. So remember only one point. If the data is available at very first location, okay, so when you are starting your algorithm, at very first iteration itself, you got the result means, then it is called as best case. Okay, and worst case means what? The data which you are looking may be available at the last, or maybe are not available. In such cases, that case is called as worst case. Sir, next one is nothing but average case. Sir, what is mean by average case? So if we are looking, okay, if we are looking for multiple datas, okay, sir, the time taken, the time or space, okay, the time or space taken for that algorithm, for that algorithm is calculated, is calculated, so based on, okay, based on sum of all the possible cases, right? Example, I will explain, sir, don't worry. For example, consider I have 11, so 12, 13, 14, 15, 16 is there. So in the first case, I want to search for 16, I want to search for 11. How many comparisons is required? Sir, only one comparison. Immediately I want to look for 12. How many comparisons required? Two comparisons. Assume I want to looking for 13. How many comparisons? 13. So three comparisons. I am looking for 14. How many comparisons? Four comparisons. I am looking for 15. Sir, how many comparisons you required? Sir, five comparisons. I am looking for 16. How many comparisons are required? Sir, six comparisons. Sir, I am looking for 17. How many comparisons are required? Six comparisons. Sir, the total number of comparisons, or the total case is called as average case. Okay, sir, what is the formula for this? Total cases by, so number of cases is nothing but the result. Okay, sir, I can able to say, sir, it is negligible, we can ignore it is we can ignore, we can ignore this case, because we are not going to compare any average case comparisons. Okay, so the data which you are searching maybe only one data. If the data is available in the very first location, it is called as best case. Okay, so if it is not available, if it is available at the end, or if it is not available, it is called as worst case. Average case means we are not moving to multiple comparisons, that's why we will ignore this. But just generally for your understanding purpose, sometimes I used, if the data is available in the middle, almost once if you travel half of the data, if you got the result, then it is considered as average case. Okay, so total how many cases are there? Best case, average case, worst case. These are the three cases. Sir, please confirm if it is clear for you people. I will take some real-time example also for you to understand. Then I will go with the step by step how you can able to analyze. Clear up to this, everyone? Please confirm. What is the total case and the number of cases. Total case in the sense, see total number of cases. How many comparisons here we are doing? So 1, 2, 3, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 6 is the total number of comparisons. I can say, so total number of comparisons. So number of comparisons. How many cases are there? That we have to find. Clear, Poonam? So why we should ignore average case? Kiran, generally we will ignore because even if you calculate, you won't get exact result. So it is something equal to the worst case only. If you calculate average case complexity also, it will be always equal to worst case. I will explain why. Don't worry. Right. Now, let us go with some real-time examples. Sir. I want to compare with some real-time example so that you can understand. Okay. I want to compare with some real-time example so that you can understand well. What example I can take is nothing but, for example, consider, so I have given, okay, I have given rupees, sir, 10,000 rupees, 10,000 rupees to my friend. Already I told this example. Sir, I have commitments. I have commitments on first of every month. On first of every month, I have one commitment is there. Okay. Sir, assume my commitment is nothing but, so almost 50,000. This is my commitment on first of every month. Sir, on 15th, okay, on 15th of every month, sir, I have a commitment of rupees 5,000. Consider I have a commitment of rupees 5,000. Sir, on 31st or 30th of, better I will write 30th. So 30th of every month, so I have a commitment. So what is that commitment is nothing but only rupees 1,000. This is nothing but what I have, sir. Okay. Now, sir, I asked my friend, Are, you have taken 10,000 from myself, so almost long back. Can you please tell me when you are going to return this amount in the month of maybe November? Okay. Then there are three options are there. What is the first option is, sir, I will return on, sir, 1st November 2022. Sir, then I think I will feel very happy, right? Sir, this case is called as best case. Sir, why I am feeling happy? Because large commitment is there. Definitely it is going to helpful, right? Now, second case. Sir, he is telling almost I will provide 16th November 2022. Sir, I can say it is average case. I can say it is average case. Sir, somewhat better, somewhat better. Not happy. Okay, good, good. Sir, it is called as average case. It is called as average case. Okay. Sir, now assume this person is giving on 14th November, 14th November 2022. Sir, it is also good. Sir, which case? It is also average case. Okay. Sir, now he is telling, sir, I will give by end of the month. Okay. End of the month. Sir, then what will happen? Sir, it is nothing but worst case, right? At worst case, when you are going to give. Okay. Okay, it is also good, but at least we are getting some amount, right? Sir, now you can able to see this we can consider as worst case. Okay. Just this is nothing but a simple example what I'm going to explain. Sir, definitely I'm going to get the money 10,000 rupees. Okay. If it is getting at very beginning, my commitment will be somewhat relaxation. So it is happy. But other than the 1st November, once if this commitment got completed, so in any date you can return. Sir, it will be good for me. That's all. Not that much excitement. Because, sir, what happens? Anyway, whether you are giving 2nd of November or 31st of November, my feeling is the same. So what is the reason I can use, but this much amount can be helpful here only. So that's why I am very happy in the best case. In the rest of the cases, you can see I am having only one feeling. So that's why I can able to understand, sir, average case and worst case both are almost same. That's why I have given two cases here, especially for Kiran. You have to see if he is giving at 14th, I can use for this. But if he is giving for 16th, I can't use for anything. That means one day before or one day after, same results will be there. So even if you are giving 16, the better you can give 30, no problem. So these type of cases are called as best case, worst case, and average case. So here also I am going to add this point again. Generally, we will ignore which case? Sir, we will ignore average case. I think you got very clear clarity, sir, why we are going to ignore. Because the time complexity will be same for average case and worst case. Okay. I hope this real-time example is clear for you people, right? Can you please confirm? Do you have any doubts up to this, friends? Do you have any doubts, friends? Kiran, you got clarity, right? Right. Next, sir, how we are going to analyze these algorithms? Okay, how we are going to analyze these algorithms? Very simple, sir. So first I will give general notation. If you take best case, okay, if you take best case, listen carefully, sir, it is going to take almost 1 unit of time. I can say 1 unit, whether it is a space or time, forget about that. 1 unit means what? At very first comparison itself, we are going to get the data. Okay, almost I can say it is a constant value, right? I can say it is nothing but a constant value. Okay. Next, sir, if you take average case, sir, how many comparisons you require to do? Definitely, if he is giving at 14th or 15th, then okay. If he is giving 29th like that, sir, compulsory n units must be required, or I can say n comparisons. Sir, if you take best case also, definitely we are looking for almost n units of time or space. Okay, this is nothing but what we have. Okay, this is nothing but what we have. Sir, if it is available in the best case, I can write big O of 1. Sir, I will talk about this big O tomorrow. Just to remember the terminology. So you have to take a capital O after that one unit, because at only one comparison. Okay. Yeah, right. Sorry. Sir, next, if you take average case, sir, big O of n, big O of n. For worst case also, sir, big O of n. Like this we have. So for calculation of time or space complexity, generally we will use big O. Sir, we have 5 notations are there. Why you are preferring only big O? Because I will explain later about that in tomorrow's session. But as of now, remember, big O of 1 is the time complexity for best case. That means when you are searching for anything, if result is available at the very beginning, then it will take big O of 1. And sir, one small requirement for you people, just have a look once. In our previous example, sir, someone asked, okay, no, I think 1 minute. Yeah, let us take this example. Okay, let us take this example. So I am searching for the maximum element. Okay, I'm searching for the maximum element. This is the algorithm what we have. Sir, best case means what? In your array, okay, in your array, for example, I have 11, so 10, 9, okay, sir, 8, so 7, 6, like this we have. Sir, I want to search for maximum. Maximum element is available in maximum element is available in first location. Sir, is it a best case or not? Yes. How many comparisons you required in this for loop? Only first comparison. But we are comparing with the remaining values also or not? Yes. That's why we will calculate a time complexity based on worst case. Remember this word, based on worst case. Sir, if you want to get best case complexity for any algorithm, not possible to calculate, because you can't predict. Because here virtually we are going to take some numbers and we will generate the flow of execution. But after seeing this algorithm, can you imagine where the maximum value is located? No. That's why for every algorithm, irrespective of algorithm nature, we will calculate only worst case time complexity alone. We want to concentrate on best case and average case. because best case definitely is going to reduce the time factor. So even if you calculate, you can't give guarantee for the next case. That is the problem. Second, if you calculate for average case or worst case, both are giving same result. So that's why, sir, whether you are taking best case or worst case or average case, the final result what you have to calculate is with respect to worst case only. Remember this point for any algorithm, not only for simple or complex, for any algorithm. But if it is working for best case, then no problem. We are the luckiest person. If it is working for average or worst, whatever time complexity we calculated is perfect. Okay, so for this algorithm, suppose if it is working for best case, at very first comparison itself we are getting the result that can be represented as big O of 1. Only in this class I am going to represent this big O of 1. We are going to never we are going to look for constants, but for any algorithm we can get the result at very first comparison if the data is there in first location. Okay, we won't consider such type of things. We will concentrate only on average case and worst case. Luckily both are same. But suppose if the data is available at 30th location, suppose if the data is available in 20th ninth location, what is the difference between these two? No. So maybe it will execute, sir, n minus 2 units. It is going to execute n units. I told, right? What is the complexity for this big O of n? What is the complexity for this big O of n? We are neglecting these values. So both will become same. Okay. So final conclusion is nothing but hence. So we will calculate. So time and space complexity. So based on only worst case comparisons. Remember carefully. Generally, it will be big O of. So what is that order? That depends. Maybe big O of 1, okay, or big O of n, or we have calculated in our previous class big O of n square, or big O of n cube, okay, or big O of log n, okay, big O of log n. Okay, sir, or big O of n log n, like this. We may have so many complexities that we will discuss how it is going to work. Okay, sir, I think so what is the importance of these cases, like best case, average case, worst case? It is very clear for you people. Please confirm, do you have any doubts up to this, friends? Feel free to ask your doubts. Just a minute, I will unmute. Some students are having doubts maybe. Yes, now you can speak if you have any doubts. Everyone please respond. Is it clear? Because this calculation is very important, which is going to be benefitable in our upcoming algorithm. So even if you take any algorithm, so whatever time complexity they are giving, it will be always in the form of big O. Remember, big O notation is used to represent worst case complexities. Okay, if you want to calculate for best case or average case, some other notations are there, like theta notation, omega notation, like that. But majority of the times you are going to see big O only, because we are calculating with respect to worst case analysis. Right, sir, please confirm everyone. Clear up to this, everyone? Right, Praveen, where you are getting doubt, can you please? No, log n log n, all these things ignore. We have not yet calculated. We will see in the algorithms. Just for your understanding purpose, I have written the sequence. So if you open any algorithm, if you are trying to search for complexity, it will be in this style only. Okay, only rarely you can able to see theta or theta or omega notations. Okay, regularly
Sir,
you
I
are
have
going to
one
see
question.
only big O. Yeah, please, Vishal.
So, in the last classes, we were discussing about time complexity, and usually in the examples, we had for loops, some if loops as well, and expressions like you explained us with the step count method. But what if we have like while loops or something like that? Is it the
Same,
same thing
sir.
we have to
Same,
complete?
sir. Any loop
Okay.
is going to take the same thing. Loop means
Okay.
what?
Okay.
Iteration. It will take same,
Okay. Okay. Sure.
right? Praveen, forget about that big O of n, big O of 1, big O of n square, all these things. Sir, please ignore this line. Okay. So whatever time complexity we are calculating, it will be measured in three formats. One is worst case, second one is average case, third one is best case. I think if you got clarity about these things, then we are going to calculate time complexity of any algorithm with respect to worst case, because in general life also we are going to see maximum worst case possibilities. So if it is working on 3 days, at first worst case, when you are going to finish the task, sir, 4 days, then we will consider target as a 4 days, then we will start working. Suppose if it is finished on first day, then okay, no problem. If it is finished on third day, no problem. If it is finished on exactly fourth day, then whatever I expected, same thing happened. Clear, Praveen? Right. So hence the main agenda is nothing but today's session: worst case, best case, average case, how you can able to do. And in this mainly we are going to focus on worst case. For any algorithm, we have to calculate only worst case analysis. Okay, right. So hope it is very clear for you. Now, sir, next concept what we have here is, sir, asymptotic notations. Okay, it is a very important topic, but sorry to say, it is completely theory concept. So the people who are hating mathematics, okay, so you people may have a different experience with this. Okay, asymptotic notations. Sir, what is mean by asymptotic notations? Sir, very simple. These are used to, okay, these are the terminology that enable us to calculate time complexity, space complexity of any algorithm. Okay, so it is used to measure, it is used to measure or represent, represent. So time and space complexities, time and sir, space complexity of any algorithm, of any algorithm. If you take any algorithm, okay, so to represent, okay, to represent this time and space complexities, we are going to use this asymptotic notations. Sir, total we have 5 notations are there. Sir, how we are going to measure the distance with the help of kilometers, right? How we are going to measure water in terms of liters, right? In the same way, how you are going to measure time and space complexities by using these asymptotic notations. Sir, the first notation which we have here is big O notation. Okay, so which is represented like this. Okay, sir, what is the second one? Second one is nothing but omega notation. Sir, I can't be able to type here, so I will represent in the diagram. Something like omega we have to take. Okay, now, sir, the third representation which we have is nothing but theta notation. Okay, theta notation. Sir, it is also I can't able to represent, just I am taking the word. Okay, theta notation. Sir, next. Sir, fourth notation is nothing but little o notation. Little o notation. In previous, we have seen big O, right? Now it is little. And similarly, sir, little omega. The people who are coming from mathematics background, they can able to see, sir, little omega. In small letters, we can, okay, in small letters we can represent. So like this, we have big O notation, sir, we have omega notation, we have theta notation, sir, we have little omega notation and little O notation. These are nothing but what are the various representations that we have to represent this time and complexities, time and space complexities. Yeah. Someone is telling, sir, omega you can represent as a capital W and small w. Yeah. Okay, no problem. You can consider it as omega notation, W. Okay. So do you remember? I think we are going to use these symbols. Big O is represented like this. Small o is represented like this. Big O of n. So small o of n. Okay. Sir, omega means like this, I think so. So omega of n. Sir, little omega of n, small letters. So theta, you know very well. Okay, trigonometric function. So theta of n. So these are the various representations what we are using, okay, as a representation of time and space complexities. But for these mathematical functions are there. When we have to go for big O notation means there is some format. When we have to go for omega notation means there is one format that we will discuss in tomorrow's session with the help of graphs. Okay. Sir, clear up to this? Please confirm everyone. Right. So tomorrow we will talk about these asymptotic notations. So after completion of this, so next week plan I am telling. Okay, next week plan we are going to start recursions, recursive algorithms. What is mean by recursion? Yeah, Ganesh, very good. You have searched for symbols. Okay. So what is mean by recursion? When we have to go for recursion, so what advantages are there with the recursion? What disadvantages are there? So algorithms, some recursive methods are there, right? We are going to work on that recursive algorithms like factorial, Fibonacci, prime numbers. Okay, n number of algorithms we are going to discuss. That may be 1 week or 1.5 week. After that, we are going to concentrate on arrays. Okay, so how you can able to create arrays, how to add an element into array, how to remove an element, how to perform searching, sorting, all these things we will discuss there. After that, I am going for searching and sorting techniques. Okay, searching and sorting techniques. So then we will introduce any algorithm strategies. Okay, that part we will discuss in our upcoming classes. Okay, right. So that's all about today's session. So if you are having any queries, you can ask, otherwise you can leave.